Hi, my name is David Napier, and I am a business development manager at EG, who are a software delivery company based in Ipswich. We leverage our partnership with Microsoft to provide data services, automation, bespoke software solutions, as well as being a trusted advisor to point you in the right direction. Following on from our tech trends for 2021, we're taking a slightly more in-depth look into 4 of the topics covered, focusing on the Microsoft technology that empowers it. Chris Pont covered IoT, Tim Nash has covered artificial intelligence and machine learning, I have covered automation, and today we are pleased to welcome Paul Henwood of Microsoft, who will be covering Azure Data Services. So I'll pass you over to Paul now.
Good morning, everybody. Welcome to this session on Azure Data Services, where I'll be giving an overview of the end-to-end solutions and services that we have available inside Azure. My name is Paul Henwood, and I'm a cloud solution architect at Microsoft, working on one commercial partner team, so with many partners implementing these data solutions. So I thought I would start with just giving you an overview of the Azure data landscape itself. It's quite broad, there are quite a lot of services, and I'll be drilling into some of these. So if we start in the top left, we've got various different ingestion services or ways to get data into Azure. So we've got Azure Data Factory, you've got the import-export service, you've got CLI or SDKs, there's lots of different ways you can get data in. We then got storage, so this is where you see things like SQL Database and Cosmos DB, blob storage and Data Lake Storage. You've then got data transformation technologies, where you'll see technologies such as Azure Synapse Analytics, Azure HD Insight, and Azure Databricks. You've got more reporting and visual tooling, such as Azure Analysis Services, Power BI. And there are a number of different other services that kind of complement these data services. So you've got the Azure ML with ML Server and Azure Databricks, cognitive services and bot services, more for the machine learning or advanced and predictive analytics. You've got more of the real-time data with technologies such as streaming analytics or streaming inside Databricks or HD Insight. You've then got cataloging and searching functionality. So Azure Search, Azure Data Catalog. I should have had Azure Purview in here as well, as it was one of the other technologies. And then you've got the more real-time ingestion or real-time storage technologies such as IoT Hub, Event Hub, and then Kafka on HD Insight. And then supporting all of these data services, you've got along the bottom here various tools and technologies that really complement and need to be used in conjunction with these data services. So you've got things like ExpressRoute for a secure connection between your on-premises and the cloud, Azure Active Directory to control your identity, network security groups to control the access to the individual services and your data, Azure Key Vault to control access or control the keys and secrets for all of your data source, Operational Management Suite to actually review and look at the performance and the running of your services. And then you've got tools like Azure Functions to automate transformations or to automate an immutable piece of code, or Visual Studio to do your development. At a really high level, that's kind of a brief intro as to the broad landscape that we have inside Azure for data services. But I'm going to drill into some of the more common and more widely used services and give you a little more detail on each of those. So really, I always find it helps to start with the modern data architecture, just to actually break it down before putting technologies in, just to talk about the various steps that normally happen when building a modern data warehouse or a modern data lake architecture. Generally, you're going to be wanting to pull data from lots of different locations. So these may be logs, this might be media, this might be files, this might be business applications, it might be databases. There's lots of data that you might want to ingest into Azure. And this might be structured data, it might be semi-structured data, it might be unstructured data. It really can be any sort of data. And generally, you're going to ingest it first. You're then going to store it somewhere. You'll then start to do preparation and transformation and data cleansing. And then you'll tend to serve that data up either to be consumed by some sort of reporting or maybe some sort of application. That's generally at a high level what an architecture would look like. If I overlay the usual suspects, the technologies that would generally fit into play in Azure, this is where for ingestion, when we're talking about a data solution, you tend to be looking at tools like Azure Data Factory. When it comes to storing your data, you tend to look at Azure Data Lake Storage for that initial ingestion. Azure Databricks is a great place to do your data transformations. Azure Synapse Analytics is a great place to serve your data and make it available to your reporting tools. And then Power BI to do your front-end visualization. So let's drill into each of these and some of the alternative technologies that you might also want to use in these places. So firstly, Azure Data Factory. So it's an easy to use drag and drop interface that gives you the ability to easily create pipelines and orchestrate all of the movement of your data across Azure. So it has a very simple UI where you can actually select the operation you want to do, for example, copy data, and choose that you want to copy data maybe from an on-premises database or an on-premises file share and land it into Data Lake Storage. So it's very much just a drag and drop simple interface. If you ever used SQL Server Integration Services on-premises, that's the on-premises SQL tool, which you can use to both orchestrate your data, but also do your data transformation. You may be familiar with the sorts of principles of what you do in Data Factory as well. So as well as that orchestration in Data Factory, you can do some amount of data transformation as well. There's a feature in Data Factory called Data Flows, which gives you the ability to have a drag and drop interface to actually change, maybe to filter out certain data, to select a subset of the data, to do unions and distincts, etc. It's really a simplified interface to be able to do that ETL as well. For those that are actively using SQL Server Integration Services on premises and they're looking to migrate a solution into the cloud, you can actually migrate those SSIS packages into Azure Data Factory as well. We have what's called an SSIS integration runtime, which means you can take a package that you've built on premises with SSIS and literally redeploy it inside Data Factory in the cloud. And that gives you the ability to easily migrate your transformations without having to rewrite it. It's also got built-in to Git, so you can control all of your source. So you've got source control over your data stores, your data transformations, all those pipelines, and it gives you the ability to hook into tools such as Azure DevOps and build those pipelines for releases to really have that continuous integration, continuous deployment. One of the good things about Data Factory is it's not just really simple to use and a simple interface, but it's pay as you go. You pay for what you're actively using. So if you're paying, if you're moving some data and all you're doing is running it for 10 minutes, half an hour, you're only paying for the amount of time and the amount of resources that are consumed during that data movement or during that data transformation. It's completely serverless as well. You don't need to maintain any servers or any resources or anything along those lines. You're simply provisioning Azure Data Factory. You have an element of control over how much it scales to help you from a cost perspective. But generally, it will just scale on demand as required. It will just scale up to a certain number of cores behind the scenes that it needs to for the particular process that you've kicked off, and then it will spin down afterwards. It also has 90 plus built-in connectors. I think it's well over 100 now. And this gives you the ability to connect to lots of different sources. As I said before, these could be various cloud sources. They could be on premises. Really, you've got data that you can move from many different locations. And also we have intelligence built into it as well. So there's some autonomous ETL and there's some AI-based content-driven copy wizard. So when you're actually going through the copy data wizard, it intuitively looks at some of the data that you're pointing at and gives you recommendations for how you might want to move forward for those transformations. And you can always incorporate predictive pipelines as well. So if you actually have, as part of your data pipeline, you're ingesting data to start with, the next thing you're doing is transforming the data. The next thing may be calling a Databricks notebook, which actually has some prediction in it, some building some machine learning models. You can actually tie that all into the pipeline as well. Just as an idea about Azure Data Factory, when you launch it, you get a UI that looks something along these lines. So it's a simple way to get started by creating a new pipeline or using this copy data wizard that I mentioned, or configuring that SSIS runtime. And when you actually start to build a pipeline, it would look something like this. So you would create a new pipeline, you'll see the various activities that are available down the left-hand side, and it's simply a case of dragging them onto the interface here, tying them together by literally dragging from the green box onto the next box to show the process or the flow that we'll achieve. And you can actually see here, you can even have logic based on successes and failures. So this green arrow on the bottom here, so if something is successful, it will call this data flow, this set of data transformation, and when it errors and it fails, it'll send an email. So you can tie all these sorts of things in as well. Next tool I want to talk about is Azure Event Hubs. Again, this is about data ingestion, but this time it's more about real-time data. So this is where you have a telemetry system or some sort of data generation tool that is generating data on a regular basis. In fact, this could be an IoT device as well. So you would actually be generating that data very, very regularly, and you'd want to push it up to the Event Hub itself. Once the Event Hub has actually got that data and it's available, you can then have a number of different consumers or readers that actually pull the data off of the Event Hub and actually then consume and use that data. So the sorts of things you would use Event Hubs for are things like maybe some anomaly detection, maybe for application logging, some live dashboarding, maybe transactional processing, device telemetry streaming. There's lots of different kind of real-time use cases where you would use Event Hubs. When you would actually have IoT devices connected to this, we actually have a very similar service called IoT Hub, which is basically Event Hubs, but it also gives you the ability to manage those IoT devices as well as manage all of the data that's being generated. To consume that data off of Azure Event Hubs, you would generally be looking at Stream Analytics. So Azure Stream Analytics gives you the ability to take that data that's been generated, that real-time data, and then actually do transformation and an analysis and analytics on that data at runtime or in real time. So you have the ability to take all of the data that's landed into the Event Hub, or maybe you want to do a rolling window of the last 5 minutes, or maybe you want to do a tumbling window, so you want to see the last 10 minutes, but maybe worth of data, but you actually want to aggregate it across the last 30. You can do lots of different things in terms of really aggregating and querying across that data. The language that you actually use is Stream Analytics SQL. So those of you that are familiar with the SQL language will be familiar with the SQL-like syntax that's available to you to actually do all of these transformations. You have the ability to not only have this real-time data, but you can actually call on and query data that's held in a more long-term store at the same time. So for example, you might have this real-time data coming in, but you also might want to look up some customer information from a database or from a data lake at the same time. And you can always join those two data sets inside Stream Analytics and continue to do the processing. This gives you the ability to complement the scenarios I mentioned previously. So doing things like analyzing real-time telemetry, or maybe doing weblog analytics, or maybe some geospatial. You can also use it for things like anomaly detection as well, because you can call out to machine learning models at the same time during runtime as well. And the idea is that it's scalable as well. So you have these scale out collections that are actually created, and you can scale up to meet the demand that you need to for your data being processed. So just to show you the interface for this is where you define the input source. In this particular example, what we're showing here is data that was used in Event Hubs, which is what this icon is here, but it could come from lots of different locations. You basically define your inputs here on the left-hand side, and then you define your query in the center window here. You can see it's basically SQL, as you can see. So I'm selecting a particular window here, and I'm counting a number of records, and I'm actually joining some data together. In this case, I'm joining the data set to itself to do some analysis here, and I'm basically looking for something that's occurring inside the last second. And then I specify my output. In this case, I'm outputting directly to Power BI. So this gives me the ability to stream into Event Hub and push directly out to Power BI so I can have that real-time reporting. Power BI, if you use Power BI dashboards, will actually support updating in real time. So you can have that dashboard on a screen and it will actually in real time update the visualizations on screen. So far I've talked about ingestion. So I've talked about that batch-based processing, which is what Azure Data Factory is aimed at, batch data processing, or that real-time in-stream analytics complemented with Event Hubs for that real-time. Now we need to come on to data storage. How are we going to store that data in Azure before we start to use it? The main technology here that you should be considering is Azure Data Lake Storage. Azure Data Lake Storage gives you the ability to store large quantities of data, petabytes of data and more, for very, very small amounts of money. You're talking for a gig of data or even 10 gig of data can be around a penny or a few pennies to actually store that data. This means that you can ingest data from all these different locations, land it into a data lake, and then choose what you want to use later to then process and pass on to these other systems and choose what data you want to analyze later. It means you don't have to be really restrictive for what data you're ingesting into a data lake. You can ingest lots of data. And it has a number of different benefits. Firstly, it has fine-grained access controls, so you have the ability to not only specify controls at a file level, but you can also do it at a folder level as well. So, for example, you could ingest data from a database into a particular folder for that database name. There can then be a folder inside that folder, which is maybe one for each table. And then the files that are inside that are each of the runs that are adding new files each time. And I can add those controls at each of those levels. I could add it at that table level folder. I could add it at the database level folder. Really, I choose which level I want. And then I can control what people can do, be it read privileges or execute privileges. I really control those as well. And that access control is combined with Azure Active Directory as well. So it means that I can use my single sign-on for Azure to actually then control who's actually getting access to that data. It also means I have automated lifecycle policy management, which means that I can configure a file to only have a certain period of life. So, for example, if I want to automatically delete some data after a year, then I can configure that to auto delete as well. And with object level tiering, it means that I can actually control the data that I'm ingesting, and I can control the storage level that I'm having. So hot for that data that I need to access regularly. I can have cold data, or I can even store it in archive. And if you store it in archive, it's cheaper to physically store your data, but it takes longer to actually query that data out. It allows for atomic file operations. So one of the benefits of Azure Data Lake is really the speed of reading the data out of it. What it actually does behind the scenes is it breaks down the file into many smaller objects, which means it can query those files in parallel. So if you combine that with storing your data in Parquet file format, it means that can be very, very quick to query, filter, and process and take that data from Data Lake Storage and push it into whatever it may be next, your database. In terms of storage, there are no limits to the amount of data you can store in Data Lake. We don't have any physical limits in terms of the maximum number of storage. We have global footprints available in all of our regions. As I said before, we've got that pricing levels of hot, cold, and archive. And really those transactions can process a lot more quickly. The whole point of Data Lake Storage versus traditional storage, and by the way, to enable this feature, when you provision Azure storage, you need to choose hierarchical storage. That's what I'm talking about here. That's what enables all of this feature and functionality. It's really optimized for Spark and Hadoop analytical engines. This is where this technology is come from. It was very much Hadoop is kind of where this is originated as a technology, as a design, and it's something that's now been brought out to be independent and just the storage piece. The other option for storing data is Azure Cosmos DB. So the idea with Cosmos DB is it's a globally distributed and multimodal database service. So really it's designed for low latency queries and low latency both reads and writes. And so we have guarantees that there's less than 10 millisecond latency for both reads and writes to the 99th percentile. We actually have financially backed service level agreements that actually guarantee those levels of performance. And those guarantees are around throughput, latency, availability, and the consistency that you specify as well. And the idea is it's turnkey global distribution. So you have the ability to specify that I want my Cosmos DB to exist in a particular region. Let's say I want to have it in North Europe. And with the click of a button, I can then replicate that over to UK West or to US. I can easily just click a button. In fact, you get a map very similar to the below. You just choose the location you want to deploy it to and press copy, and it will just deploy that database in the respective location. In terms of actually how that data is stored, there's a few different formats. They can be in key value pairs, column families, or document stores or graph stores. So depending on the type of data that's coming in or the type of use case for reading the data out, you can respectively store in the format that works best for your solution. And in terms of actually how you query that data, as I said before, it's multimodal. So by default, you've got this core SQL API, which would be the default, but we also have things like MongoDB, Gremlin, Cassandra. And the idea with these is if you've got existing solutions which are already using one of these formats on premises, it easily gives you the ability to migrate those applications to Cosmos DB without needing to rewrite all of the application logic. So it means you can also keep your application portable, so you can easily migrate it into the cloud, but you still get this fully managed service of Cosmos DB whilst being able to still, for example, use the MongoDB mode. Generally, Cosmos DB is not so much for analytical storage. It's more for if you're wanting to store that data in a very fast, performant way to read the data out, generally for some sort of application, then that's generally where it's strongest. And so you'll often see it used in things like games and mobile applications and things like that, because it's very, very fast to actually read that data out. Just to give you an idea of the interface inside Cosmos DB, if you're in the Azure portal like I am here, you basically get this data explorer and you can see all of the objects that you've created here. So I've got this items collection, which is basically another name for a table, and I can actually use a SQL-like language to query that data out. I can just right click and press query, and you can actually see the physical data in here. So there is an amount of management that you can do for the database inside the portal here. Next, for data storage, we come to one that a lot of you are probably more familiar with, which is Azure SQL Database. But with Azure SQL Database, there are actually a number of different formats or forms that actually you have to decide when you're going to use SQL in Azure. So the default is Azure SQL Database. It's just a single instance. So it's basically just a standalone database. You specify the amount of resources that you want, either using the DTU or the vCore model. And that database will then have that amount of resources, and you can scale it up and scale it down as you need to. The other option we have is Elastic Pools. This is great for a multi-tenancy solution, especially where you've got unpredictable workloads for multiple different databases. So if you've got lots of databases inside the pool, you can have them scale up and scale down. So basically you specify a set of resources for the entire pool, and then you can scale them up and scale them down as appropriate. This generally, as I said, works really well for multi-tenancy. Next, we have managed instance. It's similar to a single database, but rather than being a single database that you're specifying, you create an instance. So very much like when you install SQL Server on premises, you create an instance of SQL Server, and then you have multiple databases inside. Same way here with your SQL managed instance, you can specify the instance and then create a number of different databases. Really, the aim and the point of managed instance is for migration of SQL Server on premises into the cloud. Managed instance is closest in form to an on-premises database. So it has things like SQL agents, has cross-database query. It has functionality that isn't available in Azure SQL Database out of the box. So most of the time when you're looking to migrate into Azure, then we actually have a migration tool which will do some compatibility analysis to see if you are going to have compatibility problems. But if anything is flagged and maybe it's not compatible to move to Azure SQL Database today, that doesn't mean that you then shouldn't just look at moving to Azure Managed Instance. Again, the tool will be able to evaluate and tell you whether you can move to Managed Instance, Azure SQL Database. It has the ability to tell you for either. Next, we have Azure Synapse Analytics. And I'm going to go into more detail on Azure Synapse Analytics in a bit, but the idea is it's a hyperscale data warehousing tool. So the previous implementations of Azure SQL I've talked about have all been available for transactional workloads, or you can use them for analytical workloads. Azure Synapse Analytics is purely for the analytical workloads, not for the transactional, and it's really for massively parallel processing. It's an MPP architecture, which means that really you're looking for very large volumes of data, so 500 gig plus of data, 60 million rows plus in your fact that you're going to import into it, and then do all of your data transformation. Just at a high level behind the scenes, there's actually 60 logical Azure SQL databases behind the scenes. So like I say, it's really there for scaling and for large analytical solutions. Next, we have hyperscale. Hyperscale is architecturally closer to a Azure SQL database. So you can use it for OLTP and OLAP. But the benefit here is it's for much larger SQL implementations. So if we look along the top, Azure SQL Database has a limit of 4 terabytes worth of data. Elastic Pools is 4 terabytes worth of data. Managed Instance is 8 terabytes worth of data. Hyperscale is 100 terabytes of data. So really where these other implementations aren't to the size and scale that you need from a transactional data store, then we have hyperscale available to you. And lastly, we have serverless. So serverless is really paying for the amount that you want to use. So you can really scale down or pause the database when you're not using it and scale up when you need to. Again, there's a 4 terabyte limit in the serverless pool. But basically, you can set up things like minimum number of cores, maximum number of cores, the auto pause delay. So when it will pause after, let's say, 15 minutes of inactivity. And for these at the top, where I've been talking about SQL, you can actually have MariaDB, a MySQL, or a Postgres implementation of Azure SQL DB. So if you're needing to migrate those workloads from on-premises or from another cloud, you can migrate a Postgres to Azure SQL DB for Postgres. And the benefits there, it will be a PaaS offering, so it'll be a fully managed database, but with the Postgres interface. So that's it from a storage perspective, and probably could have mentioned on SQL, but you may already know that you can also do your data transformation in SQL as well. You can actually obviously have stored procedures, and you can use T-SQL to do your transformation. The other option for transformation we have is Azure Databricks. Azure Databricks is it's actually a little more than just data transformation. You can actually use it for ingesting data from lots of different places. So it can ingest real-time data, such as IoT or streaming data. It can ingest data from cloud storage. So you could pull things directly from your data lake, or you could pull it from a data warehouse or some sort of Hadoop storage. And you can ingest the data in. And you can create these multi-stage pipelines, kind of similar to Data Factory, in that you can actually create these workflows and then schedule those jobs to occur as required. And the idea with Databricks is it's based on Apache Spark, so it's a serverless architecture, so you don't actually have to manage the servers themselves, but you have to spin up an amount of compute, basically a size of node or capacity that you want to provision. And it gives you the ability to do lots of different workloads or inside the same workspace. So when you spin up a Databricks cluster, you can actually use it for data engineers, can use it to ingest data or do the data transformation. Data scientists can use it to do their machine learning and actually do their predictive analytics. And then business analysts can then also, once the data is being consumed, read the data out with technologies such as Power BI. They can actually connect directly to the Databricks cluster and then actually build their reports, etc. So the Azure Databricks will look like this. So this is basically the UI when you actually spin up Databricks, and you can actually control, as I said before, the notebooks, which is basically the place where you'll be doing your development. You can create objects and tables. You can create those clusters. You see there's basically links to lots of different documentation resources as well. So once you've ingested your data and you've done your transformation, then your transformation may be done in Data Factory, as I said before. It might be done in SQL, it might be done in Databricks. Generally, at this point, you're going to want to present your data or make your data available for your reporting. So you want to make it available for Power BI, or maybe you want to make it available for whatever BI tool you're going to use. Azure Analysis Services gives you the ability to build this rich semantic models. So you can actually ingest data from these various different sources. You can perform more transformations if you need to. Generally, this is where you might do transformation to make the schema and the structure a bit more business friendly. So maybe having fully qualified names. So you might rename objects. You might do some transformations specific for the set of reporting you want to create. But you can do an element of data transformation to actually build these semantic models. The idea being is once you've designed and defined these models, that people can then just connect to them, and then all of the security is contained inside here, all of the business logic and everything, and all of these models are held in memory, so they're very performant to actually query that data back out. Azure Analysis Services is based on top of SQL Server Analysis Services, which is an on-premises implementation. For those of you that have used SQL Server Analysis Services, Azure Analysis Services is tabular models only, not multidimensional models. If you do want multidimensional models, you would still need to use SQL Server Analysis Services. But the idea is that you can provision a server, you can easily then scale up to a larger server, you can scale out to have multiple servers to really meet the demands of your consumers. And lastly, from a reporting perspective, we have Power BI. So Power BI is our visual front-end tool. And what I will say about Power BI is everything I said about analysis services previously, Azure Analysis Services, all that functionality is actually inside Power BI as well. Behind the scenes, Power BI has Azure Analysis Services backing it up, or an element of Azure Analysis Services backing it up. So it has all that ability to ingest the data, build those semantic models, do that data transformation. But as well as all of that, you have the ability to create those interactive visualizations. So you can actually have a number of different charts, and by default, whenever I create these charts, I can click on one bar chart and it will filter the table or the bar chart, whatever else I've got on the screen, it will automatically filter to really give you that interactive set of reports. As well as supporting interactive reports, we also support paginated reports. Those who have used SQL Server reporting services on premises may be familiar with more of those pixel perfect reports where you might create a specific form, or you want the data to be oriented in, let's say, in a pixel perfect fashion. Then that's supported in Power BI as well under paginated reports, although you will need Power BI Premium to get to that functionality, but it is available to you. So as well as having that semantic model and those interactive and paginated reports, It's actually tightly integrated with all of our systems as well. So it has hundreds of connectors out of the box. So you have the ability to connect to obviously all of the Azure sources. You can connect to things like Azure Databricks that I mentioned. You can connect to on-premises, other cloud providers. And even if there isn't an out-of-the-box connector, we have lots of generic connectors like IDBC and REST API, etc. Or where there isn't a connector where a generic one will work, you can even build your own connectors as well. So really, you've got lots of capability to connect. It has lots of AI functionality built in as well. So inside Power BI, you can do things like forecasting on a line chart. You can do on a cluster chart. You can do grouping and clustering. You can actually call out to Azure Cognitive Services and actually then do some semantic sentiment analysis, or maybe some language translation, or you can even call out to an auto ML model. So something, if you've built a machine learning model inside Azure, you can actually make that available to Power BI and people can use that as well. And even it has auto ML inside Power BI. So auto ML gives you the ability to connect to a data source. Say the challenge you're trying to do, for example, you might be trying to do binary classification, so say whether something's true or false. And what it will do is with AutoML, it will run through lots and lots of different potential machine learning models it could use, and then just tell you what the most optimal solution is, and then enable you to use that. So it has AutoML built into it as well. As I said, it's tightly coupled in with the Azure Data Services, and then it's also secure, compliant, and enterprise grade as well. So there's auditing in place on it. You can control things like setting the sensitivity of data, whether people can export data. There's lots of compliance and security that's actually available to it as well. And in terms of consuming those Power BI reports, you've got powerbi.com to consume it. You've also got Power BI Report Server, which is an on-premises implementation, slightly more limited in functionality, but there is an on-prem version. Power BI Mobile app gives you the ability to have all these interactive and paginated reports all in mobile as well. You can also use things like Power BI Embedded. Power BI Embedded means that you can actually embed all of these reports inside your custom application. So somebody doesn't have to go out separately to powerbi.com to get to their reports. They can have it natively built into your app. Or really, there's any place that you can actually view that data. I mean, if you haven't seen demos of it, things like HoloLens has Power BI as well, so you can even view your reports and stuff like that. For those of you that haven't seen it, kind of breaks up into three pieces. You've got Power BI Desktop, which is the authoring tool, which is where you can connect to all these data sources and do all of your data transformation and build your model. PowerBI.com, where you can publish your reports and then actually share with other people. And then Power BI Mobile, where you can obviously view it on the go. And Power BI Mobile still has things like the interactivity between the visualizations. It still has, for example, natural language querying. So I can actually ask a query in natural language, like show me the total sales for this year. And it'll actually still have that logical built into both Power BI Service and Power BI Mobile. And lastly, that brings me on to Azure Synapse Analytics. The reason I'm finishing this one last is because it actually covers a number of different technologies that I've previously talked about, and all encompasses in a single solution. So this is a new service. It went generally available tail end of last year. And the idea is to really help with two sets of workloads. So generally inside an organization, there tend to be two distinct workloads that businesses are trying to achieve. The first one, I'll start with the one on the right because it's more common, the more organizations are doing this, and that's building a corporate or enterprise data warehouse. This is where you've got relational data that's ingested in. There'll be ETL that you would have created. It'll have dependable and guaranteed performance. The data will be very structured, and you'll have your security and privacy configured inside that database. The challenge can often be with data warehouses is whilst the data is accurate and secure, it can take a long time to get new data ingested into it and actually have new reports created. On the other side, you've got data lake or a data science architecture where you're trying to work with big data, so lots and lots of data. You're wanting to experiment with that data, so you're not exactly sure which pieces of data you're going to need to, or want to use. So you want to experiment with lots of data, a wide variety. You want to be able to explore it quickly as well. You don't have to want to wait for however long it's going to take for somebody to build the ETL, to ingest the data, to deploy the data warehouse, and all these pieces. And even more importantly, you might want to work with semi-structured data. You might not want to work directly with something that fits in a relational. You might want to work with images. You might want to work with video. There can be lots of different data formats. So generally, you've got kind of those two mediums or two solutions you're working on. And generally, with the former, with the data science, you want it to be easy to use, quick to explore, and easy and quick and easy to start as well. And the data warehouse, you want it to be secure. You want it to have the right level of privacy. You want it to have dependable performance. You don't want people to be hitting it with bad queries and really causing lots of issues. And the idea with Azure Synapse Analytics is it brings these two workloads into a single solution, into a single service. So Azure Synapse Analytics is now one complete solution for both data warehousing and those big data analytics workloads. So I showed a slide very similar to this at the start of the presentation where I talked about ingesting data from lots of different locations, be they on-premises, cloud, or SaaS providers like Salesforce or Dynamics, ingesting that data with a technology like Data Factory. Doing my data transformation, I might do this with Data Factory, I might do it with Databricks. I even mentioned you could do this in SQL inside a stored procedure. I might want then to transform and enrich data, so combine data from multiple sources, or maybe start to do some predictive analytics or run some machine learning models. And again, I might call this from inside Data Factory, or I might execute these inside Databricks. Or again, I might use the predict function inside SQL. And then I would serve that data in some sort of database or data warehouse. This could be an Azure Synapse Analytics database, it could be an Azure SQL database, it could be Azure Analysis Services. I would serve that, and then I'd use Power BI to consume it. And all of this would be underpinned by Azure Data Lake Storage. This is just a typical architecture that you would see prior to Synapse Analytics. And the reason I say prior to Synapse Analytics is the idea with Azure Synapse Analytics is it simplifies and creates a single tool that achieves all of those pieces in the middle, the ability to ingest that data, transform that data, enrich that data, and then present that data back out. It simplifies for not only having a single technology to be able to achieve this, but also so you don't have to configure the security and the interactivity between these different technologies as well. So you don't have to configure how Data Factory can talk to Databricks, which can talk to the database. It's a single service, so you've defining all of that security and that access inside one interface. So we break it down a bit further about what Azure Synapse Analytics is. So it's a single platform that's underpinned by Azure Data Lake Storage. Azure Data Lake Storage means that you can store data in any format. This could be structured, semi-structured, or unstructured data, and really it's been optimized for analytical workloads. It's also common data model aware, which means that if you're using technologies such as the Power Platform or Modern Workplace, where you might be using Dataverse, which is the new name for Common Data Service, if you're not aware, you might be using that common data model format. All of those technologies and Power Platform and the Modern Workplace for Microsoft, they automatically sync or have the ability to sync to Data Lake, which means that you can sync out from those sources into Data Lake, retaining that common data model format, and then still consume it inside Azure Synapse Analytics, which means tying in tools such as Dynamics CRM, Dynamics Customer Insights, Teams. You can really ingest that data in the format that those technologies are aware of and consume it and use it in Synapse. Inside Synapse Analytics, you can manage all of your data source. You can manage all of your security in a single location. You can monitor everything. And really, you've got this metadata and all this information stored in this single location. So everything's based on data. You've got the ability to ingest data. So it has pipelines functionality to be able to ingest data from all these different locations and actually call out to various different data transformations. When it comes to doing the analytical work and actually wanting to do that data transformation or that cleansing of your data, you actually have two options. You can either use SQL or you can use Spark. The benefit is basically you can define a database or you can define a Spark notebook and then actually start doing your data transformation. But what's really good about the SQL side especially is the fact that it comes in both provisioned and on-demand formats. So provisioned SQL is something that I'm sure all of you are familiar with. That's where you've got a SQL database. In Synapse Analytics, it's that massively parallel process database, but it's still just a single database that's available and it's there at all times and you're paying for it to be available all the time. You can pause it when you're not using it, but you're paying for a large set of resources. With on-demand, it changes the paradigm quite a lot. So no longer do you have to only have these 500 gig plus workloads or 60 million plus record facts to be able to use Synapse. That's if you want to use the dedicated pools in Synapse. If you've got much smaller workloads or infrequently used data, on-demand is a perfect solution. It gives you the ability to store all of your data inside the data lake, and then you query it as you need it. So you still run a SQL query as you would. What you're doing is you're running it against an on-demand database. And so when you execute the T-SQL query, it will spin up a database at that point, attach to your data lake storage, execute the query and return the result. And as long as it took me to say all that, as long as it takes to actually execute. It's very quick to attach that SQL database and execute that query. And I'm going to do a demo of Synapse very shortly to show you that capability. One of the good things about Synapse, because it has those SQL and those Spark runtimes, you can use the language you're familiar with to do the data transformations. So if you're familiar with SQL, you can use SQL Provision or SQL On Demand, or you can use SQL in Spark. If you're familiar with writing Python, .NET, Java, or Scala, or in the future R, then you can actually run those or do those data transformations inside Spark. So really, you're not constrained to a particular technology. It's really use the one that's you're most familiar with. And all of this sits inside the Synapse Analytics Studio. So this is the single interface where you can get access to all of these resources that I've mentioned below. Now, this isn't to say that Synapse Analytics is the only technology you now need in Azure. That's not the case at all. It's a case of it centralizes a lot of the data engineering, data transformation, and presentation stages, but it still integrates with everything else for the wider set of workloads. For example, it still has coupling with Azure Machine Learning and cognitive services to be able to use models that you've created or machine learning models that you've created inside. It has tight integration with IoT hubs and event hubs, so the ability to real-time ingest data and land it into Synapse Analytics. It has integration with Power BI, so you can see your Power BI reports inside the studio as well. So you're still going to use these other technologies, but really you can centralize the management of the data itself into Synapse Analytics. So with that, let me just jump across and let's start looking at it. Let's just do a bit of a demo to actually show you some of this functionality. So this is the Azure Synapse Analytics Studio. When you land into the studio, you'll see there's lots of different things. You probably won't see this recent sources when you first load it, but you'll see these buttons along the top to ingest, explore, visualize, and learn. When you first launch Synapse Analytics, Learn is a great place to click. And it's not a case of it's going to take you out to Microsoft Learn, although that is a great place. If you come into here, you'll be able to go to Browse Gallery. Now, like I say, if you don't know anything about Synapse Analytics, it's probably a great place to go to the Microsoft Docs site and go to the go to Microsoft Learn and actually read up about Synapse Analytics. But once you've read a bit about it, if you come into the gallery here, what's really good is you can have samples of lots of different solutions. So there are sample data sets for you to play around with. So be it public holidays or some COVID data or some taxi information. We have lots of data sets for you to start to play with. We also have a number of different Synapse notebooks. So notebooks are basically Spark workloads where you can actually get some idea of how to use Delta Lake, maybe how to read and write data from Data Lake Gen 2, how to create an unmanaged Spark table. You can see there are samples for solutions that you might want to create, how to create an open data set, for example. If you want help with SQL, again, there are common things with SQL. So there are great things here, such as granting access to a user, how to query how much memory you're using, how to query Parquet and JSON files, using the copy permission to actually quickly and performantly copy data into SQL. There's lots of different things here. Probably one of the most important ones I should have pointed out is this top right one, export data to Parquet files using create external table as select. This is a really good one to learn and understand. And then pipelines. Pipelines are what I mentioned. They're a form of data factory that I mentioned previously, but this is where you can do your data ingestion, your data transformation. And so if I go to one of the more complex ones here, just to show you a little bit of an example, if I click on this, how to generate a type 2 slow changing dimension, and I click on it here, this is basically going to show how I can ingest data from a data lake storage, how I can land it into a SQL database, and how this would actually build a data flow that can manage and do that type 2 dimension management. So if you're not familiar with how to build things with pipelines, then again, great place to look in this knowledge center here. Beyond that, let me just take you through the actual studio itself. So if I go to the data window down the left-hand side, what you've got here is, if I start in linked, actually, let's start in linked. By default, when you provision your Synapse Studio, what you'll actually have is a data lake storage behind the scenes that I mentioned previously. So I can actually go to my data lake storage itself. I can see the folder structures that I've defined. So if I just go into a particular folder here, maybe go to a particular file, and I can see my data. What's nice about this, though, is I can right click and there's lots of different options I get available to me. First one is this new SQL statement. So if I do select top 1000 rows and press run, what this is doing is this is using SQL on demand. So this is actually querying that CSV file that sits on Data Lake Storage. It's attached to a database at runtime and execute that query for me. You can see it took 6 seconds to execute my query initially, but now it's actually attached to that SQL. Next time I execute, it takes less than a second to query that data out. And this means that I've landed data inside my data lake storage, but simply to start looking at it and exploring it and understanding what it contains, all I need to do is right click, select statement, and that's it. I can see my data inside here. And that's if I want to do it with SQL. I can also right click and I can load it into a data frame. This time it's going to load it into my Spark notebook, and I could choose my Spark cluster, and then I can execute this against my Spark cluster and start to do my data transformation in Python or in Scala or in C# or in Spark SQL. Or I can right click and I can start to build my data flow. So SQL is for interrogating data in SQL. Notebook is for interrogating data with the languages I mentioned before, Python, Scala, .NET. A data flow, if I just take you down to data flows down here and develop, is the ability to use this drag and drop interface to do your data transformation that I mentioned. So in this case, let me just quickly create a new source here, and I can say, I want to pull data from, let's say, a set of Parquet files that I have. I want to do some data transformations. So maybe I want to join to another set of data. I want to check something exists. I want to look up to see if a value exists, or pivot, unpivot the data. You can see there are lots of different options I've got available here. But maybe I just want to select a subset of the data so I can store it somewhere. So I can simply choose select. I can then either manually or automatically map the columns from this source to my target, and maybe then just specify my target inside here and say I want to write it to my fact COVID table inside my database. So the idea here is this is a drag and drop interface to do all of my data transformations. So if I don't know how to code SQL or I don't know how to code Python, I can still do data transformations using data flows because it is really just a simple UI where I can do all of those transformations. And I can do all of that either by navigating through or doing it via the menu here. As well as that, I can do things like manage access controls. So I can grant people read access, write access, execute access, and I can control either users and groups permissions. There's lots of things I can control from that side. This is really just data lake storage behind the scenes. But what's nice is, as well as being able to see my data that sits inside Data Lake, I can actually attach other services in Azure. So for example, I can query data that I've got in my Cosmos DB, or if I've got data inside, I don't have any here, but if I'm using Azure Data Explorer, it's another tool I haven't talked about today, but you would be able to see your Azure Data Explorer information. I can see all of my data sets that I've defined inside my pipelines. I basically have this centralized location. As well as being able to see all those linked services, I can also see my databases. So here, these are actually on-demand databases. They're not physical databases, they're on demand, which means that if I run and select a query here, what this is doing is, behind the scenes, this is actually running a query on the data lake storage, very much like this if I just press run, very much like this first query that I ran here, this one here. What we've done is we've used create table to define a table on top of that view. And you can see that's all this is doing here. This is creating a table, or this is querying a table, which is pointing to some underlying storage. What's nice about this is because this is SQL on demand, I'm only paying for what I'm using, $5 per terabyte of data, and I can still attach my business intelligence tools to this. I can still connect Power BI or whatever I like into this. In fact, that's what I've done. If I go into develop in here, I have a Power BI report here, which is pointing to that on-demand database and actually querying those tables you saw inside that database to actually return this set of reporting that I've got available here. So it's actually returning, I forgot to save my change earlier, but it's actually returning all of my information inside my report. So really just this is a quick view. Probably two other things I'll quickly show is you can also have a set of SQL queries and SQL scripts. So if you want to save SQL scripts for later, be they simple select statements like this one, or be they considerably more complex, like they're actually doing data transformation using this create external table as select that I mentioned previously to actually do data transformation. You can actually store all of your SQL in the SQL scripts. You can also store your data or store your transformation in notebooks. So here I'm ingesting data, I'm doing some data transformation, I'm outputting that data to another set of folders. I can do all of that logic inside Python in this instance. So I can have all of my data centralized, all of my data transformation, and then I can orchestrate it all together with these pipelines to actually then, for example, just copy some data from one location to another. And it's a simple case of just using this drag and drop interface. So I want to copy data from my raw location to my transform, and then I can press run. And it's as simple as that. And all of this, on top of it, you can monitor every execution that you've done. You can see all your pipelines that have run, all your integration runtimes. You can see all your SQL queries you've executed even. And you can manage your different analytical pools. You can see I was running SQL queries earlier, just now, and you can see the queries that were actually executed and the performance, etc. As well as all that, you can then manage all your services as well. You can manage your databases, manage your Spark pools, manage your connections to Git to actually do all of your code control and everything like that as well, to do your source control. So really, it's just an end-to-end. And the reason I wanted to give a demo of Synapse Analytics is this integrate functionality I showed, along with this pipeline, this data flows functionality, that's what Data Factory is as a standalone product. Notebooks here to do Spark. Databricks is an element of this. Databricks is a bit more than that, but this is a form of Databricks. this is a form of an Azure SQL database that I was querying as well. So although I talked about lots of other services and didn't demo them, I wanted to show Azure Synapse Analytics because it's all encompassing really, and demos some of that other functionality at the same time. The other thing, so this is just talking about the connectivity to Cosmos DB. So what the nice thing about this is, I showed before that you can query data from Cosmos DB, but what it's doing with Synapse Link is you can actually have your operational data stored inside your Cosmos database in that JSON store, and then actually query that data out from Synapse Analytics via that link that I showed previously. And you don't have to do any ETL, any data transformation. You don't have to export it from Cosmos and land it into the data lake or anything like that. You can just query it directly, and then you can just point Power BI directly to that if you want to. And as I said before, Synapse Analytics isn't the only tool that you're going to use. It works to be combined with Power BI for your reporting, Azure Machine Learning for building and training your AI models, using Dynamics 365 Customer Insights for your insights and applications and information about your customers, IoT Central for managing and monitoring your IoT devices and assets. You've got services with Dynamics 365 Field Services, and then visual and interaction with things like HoloLens as well. And all of this sits on top of Data Lake Storage and the Common Data Model, which means you can pull data from things like Oracle, SAP, Office 365, Salesforce, or really anywhere that you like. And I think with that, I would say thank you very much for listening. If there's any kind of follow-on, I guess, would be if you can go to the Microsoft Docs site. I'd go to the Learn channel on Microsoft Docs, and you'll see lots of information about Synapse and the various technologies that I've talked about. You'll also see links to exams and certifications. So if you're interested in exams and certs around this area, things like DP 200 and 201 are great services around to become an Azure data engineer, which are all related to this as well. And we also have an Analytics in a Day workshop, which is, you can see the URL on screen there, aka.ms/analyticsiad. That's the ability to go to a free day-long training on how to use Synapse Analytics and actually get hands-on active use with these technologies. So thank you again. Yeah, thank you.
Thanks, Paul. That was very informative and insightful. I hope that everyone found this Data Services mini-series webinar useful. Any further questions, feel free to get in touch via the email sales@eg.com or on the phone 01473 558 748. Alternatively, you can also message EG or myself on LinkedIn. Have a great day, and again, hope you all enjoyed.